In this lesson, we're going to convert from radians to degrees and degrees to radians. So quick recap, what is a radian? Well, a radian is simply one radius length. So coming to our circle here, the distance from the center to the edge, that's one radius. And if I were to take that radius length and wrap it around this circle, you learned this in a previous lesson, then it might take me around there. And in fact, to go exactly halfway around the circle, it would be 3.14159 radians. That number should look familiar. That is the approximated value of pi. So therefore, the angle that opens us up halfway around a circle is actually just pi radians. So you may recall that that's from semicircles 180 degrees. Therefore, the conversion is 180 degrees is pi radians. So it makes sense then to go all the way around a circle, right? Would be not 1 pi, but 2 pi radians. From there, we can derive all of the other conversion values. So 90 degrees is pi divided by 2. 60 degrees is pi divided by 3. 45 degrees is pi over 4, and 30 degrees is pi over 6. And this makes sense because remember, pi is 180, so if I take 180 degrees and divide it by 6, I really do end up with 30 degrees. So I want you to memorize these super key conversions, which are 180 degrees, that's pi. 60 degrees is pi over 3, 45 is pi over 4, and 30 is pi over 6. Commit those to memory because it's going to make our conversions go really, really quickly. So a nice, easy way to remember this is the guy with the 6 here, right, 60 degrees, actually matches up with the 3. So it's the opposite of what you think. Then the guy with the 3 in 30 degrees matches up with the 6, that's pi over 6. So again, it's like the opposite of what you would expect. And then the one with the 4, 45, is the only one that matches with the 4, 45. So those are some like memory tricks that you could use. So now let's jump into some actual problems. And in our next example, it says, convert the given radian measure to degrees. We're going to do these in just a few seconds each. Once we're done, we're going to actually graph the angle in what's called standard position. So quick recap on standard position. We're in standard position when we have an angle whose vertex is at the origin. So I'll do this in green, whose vertex is at the origin, and then it opens up like this. See, that's an angle. But this isn't in standard position because the initial side must lie on the positive x-axis. So this is a standard angle where it starts at 0 degrees. Up here would be 90 degrees. All the way around is 180 degrees. 270 degrees at the bottom, and then 360 degrees brings us full circle. So the green angle that I've drawn here might be, well, what could it be? It's got to be between 0 and 90. It looks maybe just barely below halfway, so let's call this, I don't know, 42 degrees. Okay, that's what standard position is. The first side is on the positive x-axis, so it always starts over here at 0. Know that. Okay, now we're going to jump into some problems. Convert the given radian measure to degrees. First problem is really easy. Pi over 4, this is one of those memorized problems. Pi over 4, that's just 45 degrees. Quickly graphing it, if I know that this is 0 and this is 90, then 45 degrees might lie right halfway in between 0 and 90. And that right there would be my theta. Next, I have theta equals 5 pi over 6. So now, this is a little more complicated than what we just learned, but I want you to approach it with this perspective. First, find what you know. Okay, we know pi over 6 because we just studied it. Pi over 6 is what? It's 30 degrees. So really what I have here is 5 times 30 degrees. And I can do that math quickly. 5 times 30, well, I can break it down. 5 times 3 is 15, and there's a 0 left over, so I'm going to add it on. 5 over 6 is 150 degrees. Let's quickly sketch that. So if this is 90 degrees, and this is 180 degrees, 150 should lie between the two. It's a little closer to 180 actually, so I'm going to draw it like that. And this is 150 degrees, starting from 0. So did you see what we did? We circled what we knew, we multiplied it by the leftover number. Let's try that again for C. So what do we know here? Well, I know pi over 3. Pi over 3 is actually 60 degrees. So we have 4 times 60 degrees, which is 240 degrees. So we're going to graph that. If this is 180, and this down here is 270, and you should know these positions, 0, 90, 180, 270. Okay, know your quadrant angles, your boundary angles. Well, 240 is going to be between them, but it's a little closer to 180 or 270. It's closer to 270. It's only 30 degrees away. So I'm going to draw it closer like that. And from here all the way around to there, that's 240 degrees. Great, let's try D. So again, I don't know what 3 pi over 2 is, but I do know what pi over 2 is. And in case you don't know what it is, we can figure it out. What's pi? Well, remember, pi is the big guy. It's 180. So pi over 2 is 90 degrees. But I need to multiply it by 3. So I'm going to write equals 3 times 90 degrees. And 3 times 9 is 27. Add the 0. 270 degrees. It's not so bad, right? We're actually doing these really quickly. So 270 degrees is where? Well, if this is 0, this is 90, this is 180, 270 degrees is down there. So I'm just going to draw an arrow. Notice that we're actually starting here at 0 and we go all the way around that big 3/4 of a circle angle. That's 270. Okay, let's do the last couple really quick. So 11 pi over 6. Step 1, circle what you know. Pi over 6 is 30, and I'm multiplying that by 11. 11 times 30, again, ignore the 0. So we're doing 11 times 3, which is 33, and then bringing the 0 back, we have 330 degrees. See if you can pause the video and graph it yourself. Hopefully you had a chance to do that. So graphing 330, well, I know 360 is all the way around the circle, and 330 is pretty close to 360. It's only 30 degrees away. And so that's what my angle looks like. All right, F. F is our first negative angle. So ignore the negative. What is pi over 3? You should recognize that as 60 degrees, and the negative in front means we're negative 60. So here's how negative angles work. Instead of drawing 60 degrees, opening this way, we're going to open up, instead of counterclockwise, we're going to just open the opposite direction. So we're going to open up clockwise. So 60 degrees would be there. And that negative 60 degrees is, notice it's pretty close to negative 90 degrees, which would be down below instead of up above. So we're done.